Okay, so we're taking another look at test crosses. Let's see what we can do with this one. It's the color of sheep's wool again, and we've seen in a previous example that in sheep, white color is dominant. So we'll give that capital W, and that will mean white wool, and then lowercase w is for black wool. That isn't given in this problem, so you have to know it. If you don't know it, you have to find it someplace, look it up online. You really need to get this legend sorted or you're stuck on problems like this. So get those alleles figured out first. And you may or may not need this part, but I'll try to do it every time. The three possible genotypes that an organism could have with two W's are you could be homozygous white, you could be big W, little w, which is heterozygous, we call it, but still white because of the white dominance. Or if you're little w, then you are a sheep with black wool. So keep these distinct in your head. Here we're just talking about alleles like sperm cells or eggs or individual chromosomes. Here we're talking about a complete animal that has two copies of everything, one from its dad, one from its mom. If you're talking about an animal, you better be giving two letters like this. If you're just talking about a single chromosome, then it's okay to talk about singles. So, what animals do we have here? A white-colored female sheep. Now, this is a problem. What's the genotype for a white sheep? We know they have a big W, and then we don't know what the second thing is. It could be either way. So a white sheep is big W blank. And they cross it with a recessive black-colored male, which is little w, little w. So this is why test crosses happen, because if you have a white sheep, you don't know if you've got big W, or big little, and the test cross is a way of finding out which it is. So these two sheep have babies, and they say all of the offspring are white. And then they say from that, can you figure out what the genotype of the mother is? And the answer to this is kind of. It depends how many offspring there are, and we're never going to be completely sure. And here's why. Or we may not ever be completely sure. If we have a white lamb here, what does that mean? Big W, blank. We don't know what's happened in this case. We know that this lamb must have gotten a little W from its father, so its genotype would have to be this. But that doesn't really tell us anything about the mother. We know she could have contributed a big W, but it's unclear what else might have happened here. If we have a bunch of white sheep, every one of those will have to have a little W from their father. Every one of them could have gotten this big W from their mother. We're not really getting a lot of clear information about this blank, and so it's hard to answer the question of what this genotype is. That's the that's the strict kind of killjoy explanation here. Let me give you something a little bit better. Here are the possibilities that we're looking at. Mom could be big W, or mom could be big W, little w. And either way, dad, we know, is a black sheep. He's got two little w's. So what happens when you cross these? In this first case, every one of the lambs will get a capital W from mom, the dominant white allele, and they will get the recessive little w from dad, and they will be 100% white. In this case, when you do the cross, 50% of them will get the dominant allele from mom and be big W, little w. The other 50% will get the little w from mom and be little w, little w. So if mom is heterozygous like this, you would expect the offspring to be about half and half. 50% white and 50% black. Clearly, when they say 100% offspring are white, this is a better explanation. The problem is, and I'm being a little fussy here, but I do want to make this point, These are based on luck. This 50% does not mean that if you have 100 sheep, there's going to be 50 white ones and 50 black ones. It's like flipping a coin, and sometimes you get funny streaks when you flip a coin. I have five brothers and no sisters, even though in theory, when humans have kids, half of them are boys and half of them are girls. Sometimes you just get weird effects with probability where you don't get the kind of breakdown that you expect. You can get lucky and produce a whole string of white sheep or black sheep in a case like this, and it can throw off your calculations. You can see like six lambs in a row that are all white and say, aha, mom must be big W, big W. And then it turns out, no, you just had a funny run of luck with the chromosome arrangements. So when you see 100% white, yes, mom is probably this, but in the back of your mind, please reserve judgment a little bit because it is possible to have lucky streaks that can throw things off. The more lambs there are that come out white, the more likely this gets, and the more confident you can be saying mom is probably homozygous. And if you ever get a black sheep, instantly you know that mom has to be heterozygous. But because there's a little bit of luck built into this, it's hard to get to certainty here. You can get more and more confident in this result, but don't bet your life on it unless you've seen an awful lot of white lambs. Fair enough?